So hello everyone, very good afternoon. Myself Ekta Dubey on behalf of the Brinalytics team and our presenting partner TigerGraph and Care Rating. We welcome you all on a roundtable that is Transform Financial Services with Graph Database and AI. So before we start our roundtable, there are a few guidelines that I would like to highlight. Requesting all the attendees to be on mute when the speakers are taking the session and when the roundtable is going on. Of course, we'll have an interesting Q&A session after the roundtable and great insights coming in from our moderator, Mr. Kiran Surve, CEO with Care Risk Solution Private Limited, who is one of the partners with TigerGraph. Glad to have them on board. And now, first, I would like to introduce our partners, TigerGraph. TigerGraph is a platform for advanced analytics and machine learning on connected data based on the industry's first and only distributed native graph database. TigerGraph's proven technology supports advanced analytics and machine learning applications such as fraud detection, anti-money laundering, entity resolution, customer 360 recommendations, and so on. In this interesting executive roundtable, we're going to understand how graph database are helping financial services organizations gain a competitive advantage from digitization to drive revenue and minimize cost and build stronger relationships. Now, we are going to open the session for an interesting roundtable, which is navigating the trends and challenges in deploying latest technologies in financial services. And I'm glad to introduce our panel speakers. Mr. Debajan Chatterjee, Vice President, Fraud Risk Management, Paytm Payment Banks. Mr. Sanjeev Singh, Head Data Platform and Engineering, BharatPay. Mr. Kanayalal, Vice President, Operational Risk, Baroda Global Shared Services Limited. Mr. Amarnath Chakraborty, Vice President, Digital Analytics and Projects, Fraud Risk Management, First Abu Dhabi Bank. Ms. Vidya Veeraraghavan, Vice President, Head of Analytics, Financial Market Operations with Standard Chartered Bank. Mr. Amit Goyal, Head of IT Risk Compliance with RBL Bank. Mr. Aryan Jain, Head of Data Science and Risk with India Infoline IIFL Finance. Mr. Umang Gupta, AVP Product FinTech and Neo Banking with Kotak Mahindra Bank. And we have Kushal Bansali with India Country Manager with TigerGraph. And now I would like to welcome our moderator, Mr. Kiran Surve, CEO with Care Risk Solutions Private Limited, to take it from here. Thank you everyone for being here and taking out your time. Over to you, Mr. Kiran. Mr. Kiran, thank you so much for being here with us today.
Kiran, you are on mute. Kiran, you're still on mute.
Host may try to unmute him. Yeah, now I think you're unmuted. No one.
One second. Kiran, can you hear us? One sec.
Is Mr. Kiran facing some issues?
I think he dropped out. He should come back. Just give him a minute.
No problem. So, Mr. Kushal, meanwhile, you can start with something interesting on the topic.
So definitely, if I'm given a chance, I have many things to talk about, but I don't want to take time out of this panel. So, but yeah, thank you very much for joining in by the time Kiran comes in. So the idea here was we are doing a pretty good job on the graph side, and I'm sure you all must be keeping an eye on the technology side. Gartner is talking about graph a lot in last 1-2 years, especially. And when you look at their prediction, they're talking about graph picking up from 10% of the data and analytics projects this year to 80% of the data and analytics projects will be using graph by 2025. I see it's a huge opportunity for all of us to work on this technology. because as per Gartner, when they look at graph uses, according to them, it is not about whether you will graph or not. It's like you have to do graph. There's no other option for the big corporates, because that is the only way you can support your business. So we'll try to cover those points there. We are doing some good job with banking and finance industry. That is definitely there, and a few of the things Ekta already covered. But yeah, we are also working very closely with the manufacturing, supply chain, media, government. There are many other things. So as we get time, we'll try to cover a few things on that. I did not want to take time out from this panel to talk more on the art technology only. But yeah, anybody has any more points to share till Kiran comes back, we can talk about it.
Well, I can get started.
I think I'm back again. Now can you hear me clear?
Yeah. Yes, we can hear you. Sorry.
Yeah, sorry. So my apologies. I don't know what happened. The audio was not, so I just tried to repeat.
Perfect. No problem, Mr. Kiran. That's the part of technology to play in our life. No problem. You can start with your interesting discussion.
There is something in Tiger Graph to capture this in prediction mode.
That's great.
We'll do that soon.
So anyway, thanks a lot, and I see a very versatile group here over here, from fraud risk management, from platform engineering, people from the financial background. Nice to see some people also from the data science and risk background, some people from the fraud background. So the very essence that today the solution lines and the demands in banking have increased, and a lot is being said on the lines of credit and fraud. But when we look at the technology supporting it, we find a huge gap when we start implementing. So one of the areas where today we would like to cover big time is how did we look at, and how does this analytical portfolio help us to resolve our problems. So I would like to to start usually like a 1 minute introduction from each of you. So and in that same when you're introducing yourself, what are the challenges that you faced, or you feel that the potential where an AI and ML could have helped you in your business environment, is what I would like to share and start with. So over to you all. I mean, we can start introducing each other, so we get a flavor. And also, yes, the 3 problem statements where you could have used AI or ML better, or it could have helped better for your own environments. So we could then set up a flow on that scene. And I am sure I received a few calls. I'm good to have somebody who would like to talk on fraud, AML. In whenever you're introducing, you also could help me tell that what is a topic that probably you could start and you want to speak on, and then we can obviously have viewpoints from the other participants. Over to the team. So Vidya, you would start?
Yeah, I can get started, if that's okay with everyone. All right. So hi, Debanjan over here. I lead the fraud risk management at Paytm Payments Bank, and I have more than 16 years of experience in data science. And for most of the past 16 years, prior to Paytm, I was with HSBC. And for the vast majority of my career, I have been using data science tools to solve fraud problems. So that's all that I have been doing for the vast majority of the past 16 years. And I think the reason why AI and ML are so very relevant and they work so well when it comes to detecting fraud, and not just fraud, when it comes to detecting financial crime as a whole, is that, fraud especially is an extremely dynamic space. Like every day you would see something new cropping up. And if you had been using traditional tools, then you would have to sort of cater to each trend at a time, which is again not humanly possible, because there's such a lot of new and different things going on, right? There's emerging risk, like criminals might have moved on to new modus operandi, which we, the fraud fighters, it might be that we've not been able to catch up to those kind of that kind of thought process yet. So relying on the manual bit of work, or on the labor-intensive bit of work is not the smart way of working. The smart way of working, in my experience, when it comes to fraud or financial crime risk, is to basically, build machine learning models. And when I say build machine learning models, it shouldn't be an entirely a black box kind of a thing where you just dump everything on the model and expect it to create some magic. But in my experience, what has helped is, first, if we could try and understand how the fraudster is thinking, accordingly create some features, and then use the AI or ML tech to sort of, to harness those features and to create a model which would sort of give you a probability score as to how risky or how safe this particular transaction is, or this particular credit card application is, and so on and so forth. And just to conclude, I think the relationship with graph database is as a whole, it's extremely relevant, because increasingly, we are living in a more interconnected world. So I can come to financial crime risk later, but across all business domains, more often than not these days, you would find that any particular problem that you're trying to solve, you would find that you can actually figure out the nodes and the edges that particular customer has, or even that particular organization has, with a whole bunch of other entities that are there in your data set. And it makes sense to sort of recognize these interlinkages and again, harness these interlinkages as features in whatever machine learning models that we are building. In the case of financial crime risk, more often than not, we've seen that criminals tend to be extremely networked. So you would have money launderers being networked with fraudsters and terror financiers and so on and so forth. So then, sort of viewing the entire criminal ecosystem as a graph database becomes all the more necessary. That's all. That's my 2 cents.
So nice, Devanjan. Anybody other than Devanjan who would like to comment or like to put up anyway quick introductions? I still am waiting. Vidya, could you?
Thanks, Kiran. I'd like to take this opportunity, and thank you, Devanjan, for the wonderful insight. Basically, I'm Amarnath. I'm heading the projects and digital analytics vertical of Group Fraudrex in FAB, First Abu Dhabi Bank. So, as Devanjan rightly said, nowadays the fraud is, fraudsters are very versatile. It's more of an organized crime. And what we are observing is this is a high time where we shift our focus from traditional rule-based monitoring to a more proactive kind of a monitoring with the help of AI and ML, the cutting edge technology that is there available in the market. When I say cutting edge technology, when I evaluate the vendors, everybody is nowadays talking about models, their product capabilities. But when it comes to implementation, to tackle the real world problem, then we see where the gap lies. So most of the vendors, they fail to build a model with the kind of data that the bank is having. It's not that we'll have a huge data, labeled data, when I say, of fraud, So it is more often, the expertise of the vendor to build a model on an unsupervised learning mode, so that we can analyze the trend. And with the evaluation of graph database, we can harness this technology to get a 360-degree view to to dig out more patterns which are generally hidden from our side. So that's a brief from my side. Thank you.
Great, Amarnath. I mean, that was a good insight, and we also do understand. Graph database is a very good technology, which can actually put us on an elevated mode for the implementation part. Definitely, we'll come to that later. Yeah, please, the other guys.
Hi, everyone. Thanks, Amarnath and Devanjan, for setting the perspective, and Kiran. I'm Umang Gupta from Kotak Mahindra Bank, taking care of fintech and new banking products. And so I would like to take the direction towards how, from product management perspective, how this entire data and AI is playing a role, and how graph data can help, because that's another part. So let the customer come in, and that's an important part which also helps can be solved from AI and data. So it's largely to understanding of the customer. So thanks to the COVID and technology, everything, customers now are interacting directly with the bank, either through a DIY, etc. So the entire earlier relationship or understanding of a customer that used to happen with the relationship manager or an RM, etc., is now moving to someone who's on either a virtual RM or a chatbot, etc. And that's where the entire understanding, because of the 360-degree understanding of the customer, you have multiple touch points. The graph data or any other AI and ML can help you in understanding and guiding the customer in the respective. We'll take more of this topic forward in our subsequent discussion, but I just wanted to highlight it's from product perspective also, it's very important to have a more structured understanding of the unstructured data with the help of a graph data.
Yeah, nice one, Oman. Thank you. Yeah, the next team member, please.
So, hi everyone. Thanks for this setting of this call and roundtable. So, I'm Sanjeev Singh. I'm heading the data platform and engineering in BharatPay. I have total 7.5 years of experience. So, basically, coming from data platform and engineering background, earlier it was like what I was realized like the data requirement is only for the data science team, the data analytics team. But nowadays, like I mean, India is emerging for the startups, and so now I realize that every team, every bits and pieces, they require data to analyze. Not even the data science team, not even the analyst team, but the operations team as well, the sales team as well, the marketing team as well. They want to play on top of the data. They want to understand where is my business is going, where is my operations is going, where is my customers is going. So the requirement nowadays is to you have to as a data engineer and when you are heading the platform, you have to make sure that you are strategizing the data or storing the data in such a way so that they can easily access the data, and whatever the size of your data, whatever, like as Umang is mentioned, the unstructured and structured data, semi-structured data, or any type of data. The operations team or sales team or marketing team, they don't care. They just want to query the data so that they can understand the data, they can visualize the data, and in a sense, so that they can take a call onto the business, so that they can easily understand what's going in my data, where is my business is growing, where was we were last year or last month or last week, and where we are doing today, irrespective of data science team. Even in data science team, people are more they can query the data, they know the coding and all these things, so it's quite easier for the data science team. But for the other team, so it's very difficult if the data is not stored in well mannered. So in that case, I think that is why the data warehouse, the data lake, and the graph database kind of database system is coming, and people are feeling better, feeling easy to get the access of the data, to get meaningful data, which was not earlier with relational database. And as mentioned in the graph database, we have nodes and edges, like as Devashish mentioned. Considering the data representation is quite easier than the RDBMS, you can run your complex query, which was not easier in RDBMS. Like in RDBMS, you have to definitely we have a different table, you have to join the table. But think for a guy who know any knowledge of tables or RDBMS, they don't want to join the table. So that is very easy in the graph database, where they run the complex query very easily. There is no requirement of join the relationship of use cases, and that is why they can easily query the data to get the recommendation of the data, to get to as mentioned, the fraud detection they can do. They can leverage their customer to understand their 360 degree. And I think that is why most of the banks, even in the BharatPay, we explored a graph database, and a few of know as well. Like we are going to have a bank soon. We acquired PMC Bank, and soon we are going to have a small finance bank, Unity Bank, and we are going to launch. And we got all the compliance and rules and regularities from RBI. So yes, and that is why the reason we also love to explore this graph database. And other banks, as I as I remember, like Citibank, SB Bank, Global 50 Bank, these are using these graph database because of, I think, the first and foremost thing, before jump into fraud detection, credit scoring, these are the complex terms. I think the first foremost thing as a data platform engineer, I always rely that I have to make sure that people can access the data very easily, so that I can make their life easy. They don't want, I mean, they write query, and it's, if it is taking 5 or 10 minutes, it's I mean, then it's very I mean, it's very painful for me or for them, how they understand their business. So I think graph database, the first and foremost solving the problem is to strategize the data, so, and storing the data in such a way that anyone which is very, I mean, less understanding of the technologies and tools, they can easily access the data, they can understand the data, they can understand their business, they can understand the value of whatever the offer or anything features is going on. Then definitely the next step is the fraud detection, the credit scoring, the data lineage, also understanding in the graph database. Then obviously they can understand their 360 view of their customers, and most of the things definitely they can grow. So this is what I understand from the graph database and comparatively to the other databases. Thanks a lot. Any question? Love to answer.
Thanks, Sanjeev. Thanks for your introduction. Good to know that there is a versatile way, we could probably look at helping you. Definitely. We'll come to that later. Right now, okay. Over to others. Please introduce yourself.
Thanks.
Okay, I can go next. Hi, I'm Vidya Veeraraghavan. I'm a data evangelist. I solve business problems using data. I'm passionate about analytics and newer technologies. So I've had almost 2 decades of corporate experience, predominantly in banking domain. I'm currently serving as Vice President, Head of Analytics for Financial Market Operations with Standard Chartered Bank. Earlier, I used to work for Citibank and almost 7-8 years with fraud analytics. When Deepanjan mentioned the older traditional ways of fraud, prevention and fraud detection, I was like taken, a few years back to see how we were working with large amounts of data in Excel sheets, and even the people who gave me handover, they were talking about sheets and sheets of data which comes in, people sitting on the floor reconciling it, finding out where the pattern is, and it used to be very crazy. Graph database is not very new concept, in my opinion. Indians, when you want to introduce somebody, especially Indians, mami ka chacha ka cousin ka beta, or this is how people introduce each other. So relationship matters a lot when it comes to identifying individuals or relationship transactions. So graph database basically helps you to put a lot of these relationships in a single place where you can easily understand. So I cannot comment a lot about Standard Chartered Bank, what it does, because I don't represent. But as a data evangelist, this becomes a very, very easier way to identify individuals. And as we have all read and know about the graph analytics, you can combat fraud, you can combat anti-money laundering, and you can have a 360-degree of your customers. You can identify which demographic can actually work for your products. You can design your products based on the patterns that come out of the graph analytics. So there are a lot of use cases which have been tried and tested. My only hope and wish is that graph analytics picks up more and more, because it's easier to adopt, it's cloud-based, and you also can scale it up in a much faster fashion. I would like to talk more about how the COVID has impacted, whether it has impacted this or it's a blessing in disguise. That's what I want to focus on in our further conversations. So let's hear from the rest of them also. Thank you.
Thanks, Vidya. Over to others.
everyone. Thank you for inviting. I guess already a lot of discussions have started, and it's a very varied discussion. The way Sanjeev talked about data engineering, while Devanjan talking about the graph databases in detail. I'll keep it very brief. So I had close to 9 years of experience now in this field, currently heading the data science and risk vertical at IFL Finance, and worked in different domains in the past, like telecom. I was with Vodafone earlier. Prior to that, I worked with RBL Bank. So given this journey, if I talk about, there is a huge shift happen in the way data analytics happen in the industry. A lot of rule-based analytics was crazily amazing for a lot of business folks. But now if you talk about that, you look like a old school mentality. Everyone wanted to talk about AI, graph databases and all. But fundamentally, one thing which I wanted to call out here is, which I believe is whether it's AI or whether it's machine learning or whether it's anything you call it, ultimately, whether it's fraud or risk, understanding consumers, understanding how someone will come to your system and try to do the fraud is the most important skill anyone can have, whether at a junior level or a senior level. All these technologies are definitely helpful, like graph databases is giving a different way the whole fraud analytics can be done along with different use cases. But fundamentally, all these machine learning models, I believe, as they say, right, garbage in, garbage out. Whatsoever garbage you bring in and you put in the model, it will just emit out the garbage out, right? So the most important skill I think still pertains here is how smartly you think that the fraudster will do the next step. And that's why I guess fraud is one of the challenging problem statement. There are a lot of companies who only do fraud still. I think they will not themselves call themselves as an expert in identifying a fraud. It's a very depthful topic. You have to stay ahead of the fraudster, what fraudster is thinking. But I guess, yeah, this is a nice forum. We'll take a pause here. Probably once the discussion will start, we'll add in more thoughts around it. Great.
Sure. Thanks, Aryan. Thanks. Amit, over to you.
Yeah. Hi, everyone. Amit Goel this side. I'm with RBL Bank. In my current avatar, I'm head of IT risk and compliance and also looked into financial inclusion market. So yeah, for me, working with regulators day in, day out, compliance becomes a very important tool, right? And reporting to the regulator on a daily, weekly, monthly, and so on and so forth, it becomes a little bit of a challenge. And when you say you are compliant on something, suddenly something pops up and say that you are non-compliant in this area. So the AI tool actually, I feel, helps in identifying those areas and being a little bit ahead before the regulator can come in. Right now, the right word is penalize you, because that's something which you people are hearing day in, day out. Every second bank is getting penalized for something or the other. So something which helps in compliance is something which AI can support us. And yes, it's a nascent area in the compliance bit right now, the AI piece. Exploring it right now and figuring out how we can use it, talking to multiple players around it. And I suppose this will help us out, give me a little bit of insight from whether we can use the graph database to being more compliant and being more watchful before even the regulator comes and tells us that you are non-compliant in specific area. So that's a brief. Happy to discuss and take it forward from here on.
Thanks, Amit. Thank you. So, yeah, good. Thanks for all the introductions. It was great. And the introduction also had one flavor of whether the topics, how they should move. But let's get into our first topic, though I do strongly agree that artificial intelligence has helped finance, but has it made it a revolution is something which is a debatable topic. But yes, let's start on to the first line item. Do you all? I mean, we'll all have viewpoints definitely. But when we say how AI has started a financial evolution, how we think that artificial intelligence has added value to the business lines, what we carried. Like Amit said that, okay, fine, today compliance changes. Devanjan said about things which are on the fraud control level, continuously churning out fraud. Amanat spoke about the implementation pieces, Vidya spoke about, yes, how, and I still remember when a simple master data management had to be done. And Kushal, this is history. I do this for 28 odd years. I remember in years I used to write Java code to get those, segmentation done. And I used to be called a cat. Oh my God, can this guy do this? And thanks to technologies, these are coming very close to us. But is it, how can it actually bring a financial revolution, or is it bringing in, is something what I want to hear from each one of you. Let's contribute towards this topic, how AI has actually brought a revolution of financial understanding, betterment of your business, is what we would like to hear from you. So over to the forum now. Thank you.
Interesting point, actually. I'll take it forward. So for example, long back, people used to visit different branches, etc. The branch manager who used to understand the customers used to take care of the fraud also, as well as the relationship also, and the business also. Later on, things got CBS came and everything into the system came. People became comfortable roaming around different branches and everything, but still few banks like Catholic Syrian Bank or your cooperative bank still continue with that corporation model, and they were able to still get the customers even in this today's time where you have a private banks, etc. in the market. Now, moving to the third phase, which because of COVID and everything and the technology, there were many people who either jumped on the DIY and digital mode, or there were many people who were using only the earlier only the physical mode. But because of COVID, they got forced into, and that was the time most of the product managers like us got the chance that yes, now we have these people also interacting on the digital platform. But what happens when these things are happening? Parallelly, you're having too much of a data that is coming up. With the advent of account aggregator and OCAN, etc., you're getting more data also for processing. But once you start mapping all those things, there were initially three problems that the branch manager or relationship was working on. First one, who is a kind of a fraudster who is doing too much of a deposit or too much of those transactions, which can be suspicious one. Second part was which products I can manage or which person to give a loan on. And third person, how to increase the business or relationship with the person, because I have an understanding. So I understand Amit or Vindhya very well. So that's a short business line. This entire three proposition which was happening because in the physical world, now because of AI and thanks to COVID, can be given by most of the fintechs in time to come via the digital or a DIY mode or a chatbot or a later on maybe because of the way Facebook and everything is working on, maybe in a metaverse world or a digital virtual world. What underlying everything of this is whether you are able to understand the customer from all the angles, which product to offer, which all the customers are suspicious, and do I have a good relationship? This itself is bringing the entire financial revolution and supporting this entire revolution. Otherwise, people would have moved back post-COVID or post this lockdown will move back to the older world, but they will not now because these fintechs, whomsoever understands the customer best, will be able to garner or will win this situation. And that's the reason the entire fintech revolution is bringing it up, and AI has a major contribution into that. Over to this for the views.
So yeah, I guess just wanted to add in. I think in terms of a revolution, I believe if we talk about machine learning and AI, it may be the new terminologies for a lot of industries. But if you talk about banking, and even if you go to the history, logistic regression kind of a model was first developed for banking, I think in late 90s or early 2001 or 2 types. So banking as a field is all, I think have benefited a lot from all this kind of a science. And I think this is the domain where you need to use all this science to make a lot of product enable for your consumers, as well as make your own portfolio safer and richer, right? Not only this, I guess a lot of education around financial literacy is being enabled by AI. There are a lot of companies who is giving a recommendation that which loan product is best, or which stock market you should invest in, or which mutual fund you should invest in, which is little personalized information, what you wanted to achieve in your life, what goals you have. And all these things were earlier done again with the help of some manual persons, right? And the second angle which I wanted to bring is the scale, right? So for any business to grow in, you either if you rely more and more only on the human resource, you won't be able to reach that scale, right? And that is the power of an AI. You don't probably need thousands of underwriters or credit managers, to do the job, where some of the tasks can be automated using machines, right? You don't need people to, really match the KYC documents when there are technologies like OCRs, name matching, address matchings, which is enabled by NLP or other branches of AI. Other than that, I also kind of feel that it's just a beginning. Still, I think we are still scratching the surfaces. There is a long way to go, and we have seen only the software side of the AI things. Now, as more and more hardware parts are coming in and making our life, which we talk about smart stuffs, smart fence, and XYZ kind of things, right? Which is the next kind of an evolution where we are going to marrying a lot of hardware things which we see around, along with the AI enabled devices as such. So I think, yeah, there's going to be a very interesting, revolution which AI going to bring. It's already started a couple of years back. Yeah.
Thanks everyone. The thing is, like post-COVID, I mean, if you look at the current trend, the way we do transaction has changed. Like how we used to do the transaction 10 years back, we're not doing it. We are just scanning a QR code, putting our MPIN, and the transaction is done. As simple as possible. I don't remember when last time I visited a branch. So that's the kind of revolution currently is happening. And when we talk about AI has both the sides. One, all the good side that we have seen. Now there is a other side. I would not say it's a bad side, it's a challenge. Basically, we have to balance between the technological advancement and the customer experience. Too much of an automation or too much of an AI-assisted journey in any of the product may also adversely impact a certain segment of the customer. Say, if I am, repeatedly putting something in a customer screen that he doesn't require, but still my model is throwing it up because of some garbage input. Somebody mentioned about inputs and all. Yes, that leads to a negative impact on that customer side. So that's one point which should be very careful about when we talk about implementing any kind of an AI assisted journey or any AI assisted feature in our product line. Okay. Secondly, during the COVID, what we have seen is there is a shift towards digital transaction, and that also opened up a new area for the fraudsters. There were a lot of fraud that was happening. In fact, the fraud that OTP compromise kind of a fraud that we increased many folds. What we have seen, my previous organization, Axis Bank, we've seen a lot of frauds happening day in and day out. So that point of time, AI also helped us to, unearth some of the patterns, because if we talk about the data, because the transaction volume that we see in India is very huge. We were having around 300 plus transactions per second. So the modern data problems often involve many-to-many relationship with heterogeneous data that needs to be set up, navigate deep hierarchies. We need to find a hidden connection between distant items and discover the interrelationships between the items so as to predict the thing, what the fraudster is thinking, where are the vulnerable areas that needs to be plugged in to prevent the future fraud. So all these things, comes when we implement the right set of models, which are trained with the right set of data, not with just for the sake of implementation. We implement some model and somebody rightly said that we expect the magic things to happen. That doesn't happen like that. We have to give the correct set of data. We have to train the model correctly, tell the model that, yes, this is how it has happened in the past. Now you tell me how it's going to happen in the future. So a balanced approach is required, wherein we should implement both, trained as well as, untrained, structured and unstructured data. Both should go hand in hand to get a right blend of output on it. That's the way I think we can harness the true potential of this feature, this AI and ML.
So when we talk about financial revolution, right? So I just wanted to give a small example. Probably a use case can help us understand this better. So when we moved away from letters and then to emails, that was a revolution, right? When we moved away from calculator to our phones, which helped us to calculate, so that is kind of a revolution. When we moved away from touchpads or the keypads to smartphones, that's a revolution. So what kind of revolution that has happened in financial world is that the digital transformation, which is assisted by whether it is cloud technology or your artificial intelligence, or you have your machine learning models, which can help make your customer experience a wow experience, or your fraud detection more robust, or your anti-money laundering saving you from the regulators. So I think that is the kind of revolution that we're talking about. So what happens when you have a lot of data? Now that we have a lot of data, we try to store it. Not everything is useful. Some of them are quite useful. But the problem arises when you are an established entity and you have 1,500, 1,600 different systems which carries, a lot of data. So as a credit card customer, I might be sitting in one system. As a savings bank account, I'm sitting in another system. So unless and until there is a relationship made along all these, there will not be a single point where this can connect. So I think that is where the revolution is happening, where you make the connectivity within your systems. You don't even have to step outside to see what this customer is dealing with another bank or another financial institution or an insurance company. Within your area of work itself, you don't have the connectivity fully. So this is where the revolution is happening. That's what I see that AI and ML are trying to bring about. So that I wanted to add.
When I sort of listen in, on the major narratives that are there in the analytics fraternity as a whole, I typically hear people speaking about how AI is helping us to solve complex problems, and then there is another parallel narrative as to whether machines can cut jobs. So these are the two major narratives that go on. I think the third narrative, which is equally important, but which somehow is missing the action, is how can we design better AI systems so that the combination, the human to machine combination, that works in a seamless fashion. So I'll give you an anecdote just to explain my perspective. So basically, there's this, we've all heard about the Deep Blue machine, right? The AI machine that plays chess, and that sort of brings about this entire existential crisis that machines are smarter than us and they are after our jobs and stuff like that. There is actually a different kind of chess competition, an international competition. It's called cyborg chess. All right. So over there, what happens is, let's say you are a chess player, and then you have a computer with you. The computer suggests various strategies to you, and then you apply your brain to choose which strategy you are comfortable with. So independently as a chess player, you obviously you have to be quite skilled, and also your computer is good enough to suggest intelligent strategies. So basically, it's a combination of humans and computer brain. So what we've seen is in these kind of cyborg chess competitions, if you follow, you've seen that it's not always the case that the winner has the best machine. That's not always the case. The winner always has those kind of machines where the interface is more seamless. The friction between the human being and the machine is the least, so that the computer knows exactly what the human wants, and the human is able to interpret exactly what the computer is suggesting you to do. Similarly, if I sort of extend this analogy to the kind of business problems that we are trying to solve, let's say I'm a credit risk professional, or I'm a fraud risk professional, or ops risk, and so on and so forth, and I've been given this task to build a model. On and off, I've seen, these days there's this tendency of a lot of people, to sort of to dump everything on the AI and then just expect that something magical will happen. Like recently, one of my friends, he works at an analytics firm in Singapore, and they were trying to build a model for credit risk, and he was saying that there's this one intern possibly who had used, and they had this historical data of credit risk defaulters and so on. So the person had tried to use transaction date as a feature in the model. So you're using past transaction dates to, which doesn't make much sense. Now, so I keep hearing these comments on and off, wherein We are just, it's a garbage in, garbage out, as someone was referring to. So long story short, I think AI is as good as a person, who's behind the computer. And just on a concluding note, of late something has happened post COVID that has sort of encouraged me to sort of think further along these lines. Each day once the pandemic hit us, whenever I was sort of scrolling across my LinkedIn feed, I had these whole swarms of people who are using machine learning to try and predict COVID trends. And most of those trends led to nowhere. And that got me thinking, like, if I do not have a medical degree at all, and I know nothing about COVID, I'm just a layperson as far as medicine is concerned, and all I have is a fancy AI algo at my end. How good is that in predicting COVID? And as we've seen over the past 1 year, more than a year, it doesn't do that great of a job. So long story short, I think that is one conversation that is sort of slowly emerging into the mainstream narrative, that AI is obviously, it's an extremely powerful tool. It needs to be handled with care. And that is something which the younger people are sort of moving into. This kind of discipline needs to be trained on.
Great insights. I'm sure, Kushal, you need to organize more sessions, because we've not been able to cover the first one as well.
No, I understand, and it will be,
but it was really nice. So I did not want to, but it was great flow of thoughts, and I appreciate that. Yes, the line of Amarnath is very important, where implementations are very important. We need to know about that. We also understand in the fintech world what Umang told us, how quick decisions can also lead to fraud. And very important, Devanjan brought a point, the domain has to be understood very well, where, before you do anything. And that's why we are there. We are not replaced completely by AI. Technology is replacing us. But yes, this world is increasing faster, and what it has to bring is somewhere, use those technologies to benefit us. So, how, so I would like now, because it's already 4:20, I want some time to also look at the graph database and AI to transform our financial services, that point, because that's more of something what we all are interested in. That we spoke about our problems, right? Like Amit said, there's a compliance changing. Sanjeev said about the data platform, because now he's going to get into a bank. His challenges are going to be more. So somewhere, Kushal, I want to take this conversation to one level where, actually tell us how Tiger Graph or any graph database, let's not endorse any, how graph databases can help us big time into, I mean, I do understand we used to build those network algorithms years together, put those elasticity indexes into the program, and then we used to get something out. In our old IIM days, we never had any softwares, right? So we used to write codes. But how easy it has become, or when we say we want to find a particular pattern. Now, I wouldn't say, and I always, Kushal and I have an argument, just for all of you. I always tell them, it's graph database. It's just one way of looking that it is only fraud analytics. But think of people like us, who have really, got a lot of energy had to put to, even to find propensity or elasticity between a customer, make a network, or make a cluster of similar customers. I'm sure we all, I mean, have gone through pain to create that. So just a view, it's 4:20, the right time for the technology team to tell me, how exactly does it happen? And then probably the last question, Kushal, we should take it after that how, after looking at the technology, do you find it as a game changer? Because we've spoken more on AI, but graph database is not only AI. There's a lot more, a simpler flavor that can be used just to increase my ROI for acquisition of customer. how credit patterns can be matched to spending patterns. So these are some angles which I mean I will keep on talking in multiple forums. But graph database, the way we are pitching only as fraud is wrong.
Right.
And
Right.
this is my first strong statement to Kushal, Joe, everybody, that there's a world beyond it. There are many more problems in the financial world that I can solve through graph databases. Anti-money laundering, you speak as a financial fraud, but there are multiple other things also that can be done. So, the third question we would like to take after a short demo, or if you could run us through what graph databases can exactly do. Thank you.
So before we jump on that, Kiran, I really appreciate all the insights, and definitely you all have been into this industry for long. And on a personal note, I come from a banker's family. My dad used to be a banker. He just retired a few years back. So I think he was in the bank for 35 years. And you will be surprised. I come from the day where you used to go to the bank, and they will have that passbook and the ledger, and you fill a form, and they three guys will sign, the register will move, and that's the only way you can get your money basically. And if you go and say I need this much money suddenly, and then it's all sort of they will have asked personal question, why are you needing this? You can understand what I'm talking about. From there today, as Sanjeev covered, Umang covered, that suddenly the product manager are being asked because of the pandemic that everything has to become digital and you have to work on these. So we are talking about a complete shift, and it is not unusual, right? If you look around you, we are talking about a time when our whole building of 50 flats used to be only one car. I'm talking around 20 years back. But today every flat has two cars, and we have no place to park, right? And the electric cars we are talking. So I think all sides of our life, the evolution is happening, and good and bad things are happening. The number of people used to die in the cars that time were definitely less because there were no cars. But now the numbers have increased because cars are there. But at the same time, you have benefits of car. You all travel by car, utilize the time while you're traveling, take benefit of that. New employment things are coming. So I think the same technology is also moving in that direction. And when you look at graph, as Vidya very nicely covered, graphs are not new. Graphs have been there for last close to 20-25 years. However, look at the size of the data and the completeness of data. I will not say completeness from the all compliance per se, but the availability of data now. Today, if I want to do a transaction with bank, I have no other option but to do it digitally, and that's why you have my data with you, and that's why you can work with that. And that's why graphs are becoming important. One, you have the data availability, you have huge load of data which you can't process with. I think Sanjeev covered where how do you write those joins with Oracle and run query and wait for 5 minutes. I have a customer who takes 3 weeks for a query to answer. Actually, they know it. So whatever changes they make, and when they get their output, it's 3 weeks old actually. So today, whatever they are answering to their customer, they confirm that they are answering in blind actually, that they are lying. They know that information is incorrect. There is no other way. Graph is actually solving that problem. The way graphs are designed, the way you store data, it is already related. And when you run a query, it actually responds, in that direction. So as Kiran said, graphs can solve this problem by relating data. And when you look at your bank, I heard multiple things. There is a good trend which is coming from Gartner or somewhere I was reading. They said, know your customer. You all know about KYC. But when you talk about know your customer, they're talking about maybe 2 years down the line, you want to be in a position where you want to decide as a institution which customer you want to deal with, which you don't want to. You should have a right to cut on the bad customers because one, they are bad for you in terms of risk. Second, they don't bring the business value to you. And how do you cut if you don't know your customer? And once you know your customer, definitely the risk and all these things are definitely important part. But the other side is if you know your good customers, you can cross-sell, upsell, handle them well. And that is the way actually it actually helps your business. So as Kiran rightly said, it's wrong thing to say that graphs only help in the fraud way. But yeah, it's all around. And Kiran comes from Care Risk, which is basically the care rating companies, a part of that group. And ratings are what? When you're looking at your exposure on loans, you want to see that what is the risk side on that. And there are many factors you want to look into. And we all know that when we are looking at a loan for a particular person or a particular sector, every sector is interdependent on the other sectors, right? So if one sector is getting disturbed, you will say the entire sector will be getting impacted. How fast you can work on that, that is something, there's one more side which graph will. So once you have a graph in place, possibly it's limitless to think about the possibilities. I will hand it over to Pawan, who will try to use some slides and
just one liner, like Umang, you are from fintech, right? Umang does a lot of the fintech. So, Umang, one of the most interesting cases, because rating is one thing, but what Kushal has brought about is a very important thing as an economist. See, fraud is not only where we talk, or relationship is not only when fraud happens. Ancillary units downwards, when a core area like energy collapse, okay, or an infrastructure collapses, think of the effect what the other industries. And very important for Amarnath, you come from, most of you you all are from banking. And when we keep on speaking models, but let's look at pure play data science with a domain expertise. How will your complete portfolio fall down or go up because of key pointers is a very important use case. And that's what we are trying to already build on Tiger Graphs. Once I build it, I think most of you banks can start using that. It's just an algorithm properly. So we're doing it with the large country-based economy. Okay, I don't want to expose much over there, but we're using graph databases at country level. And somebody, Kushal, ye aisa nahi hota hai. I just told him, guys, look, wait, let the domain guys do the job. We understand, and that's where these flavors are important. And why I pointed to you, Umang, because in fintech, you're continuously giving, but what about monitoring? Monitoring nahi hota hai. There is no algorithm. Heaven cannot build that algorithm, right? But science can actually point you. So again, as somebody told me, right, it's not magic. It's not magic, but there's a huge amount of energies we as domain people need to put to utilize the technology in the right constraint. Anyway, it was just a pointer that supply chain management itself is a huge thing. Kushal, I think you can check with the bankers. They agree. You do not. There are multiple uses which we can, look into real business problems which we don't look at. Sure.
I agree.
Over to Pawan. Sorry, Pawan, took a couple of minutes.
No worries, Karan. Let me just share my screen very quickly. Okay, so let me know if you can see my screen.
Yeah.
Yes.
Yeah, we can see.
Yes.
Okay. So we will talk about unleashing the power of graph database and AI to transform financial services. And as and when the discussions were happening, right, I kept a very high-level slide actually. But when I hear from people here and I understood the depth they understand of things, right, I kind of added a couple more slides which might be more interesting. And some of the content I will just skip through, right, because already we have covered in our previous discussion. So feel free to stop me if you have any queries, since we have a very small group of people here, very focused people, right? So I'm a senior solution engineer for Tiger Graph here in India. And today what we will be talking about is graph analytics and why we need graph analytics. A little bit about Tiger Graph and how Tiger Graph handles fraud and AML, and a couple of our customer use cases, which we can kind of cover if time permits. So I think we already kind of covered this. You can think the way human mind thinks is in the way of graph, basically, right? So if I ask about Eiffel Tower, basically you will always know that, yeah, it's basically located in Paris, right? Which is a city. I mean, some of your friends might have visited there. You'll remember their faces instantly, right? So I think the way people think, the humans think, is in the manner of kind of things are related. They are not standing in silos, right? But we kind of ended up having our databases, our systems actually kind of designed in silos, connected by foreign keys and primary keys, right? And so it's not just for humans to understand a graph much more easier. It's even for machines. That's the point I'm trying to make here. So even machines work much more faster in a graph sort of scenario, because your entities are related to each other. They are not just kind of standing in silos. Uh, Charts are not graph basically, right? So obviously not for this audience, you already know this. So I think Kushal already mentioned this. By 2025, graph technologies will be used in 80% of the data analytics innovations, 80%. And today we are at 10%. So you can understand the kind of explosion which is going to happen, which Gartner is predicting. And basically, obviously, everybody will move to graph. There is a reason behind it, and we will cover that in subsequent slides. So graph is also selected as top 10 trends which will change the business in 2021. It's one of the key trends, right? Now coming to the main point, right? So I mean, why we always talk about graph databases, and yeah, things are connected. They have a visual appeal, right? But it's also important to understand why they work faster. Why, when you want to kind of run some sort of ad hoc query, it's much more faster versus a relational sort of setup, right? Or if your data is lying in Excel, obviously you're doomed, right? But yeah, if it's kind of situated in, let's say, set in a SQL database, right? The way it is stored in a SQL database or a traditional database is very different from a graph database. Graph database actually stores the pointers from Pawan to Kushal and to Tiger Graph, that these three are connected, right? So if you're searching for Pawan, you don't have to scan through the whole table. You can just find Pawan, and Kushal is a colleague, and Tiger Graph, that's where they both work. It's that itself gives a lot of kind of performance addition, right? And much more easier for the system to navigate. So relationship is basically a first-class citizen in a graph database. That's the whole point we are trying to make here. And that is something which the traditional systems, which are more suited to work for an operational sort of system, right? Is kind of is more suitable for those kind of situations, but not really good for analytical sort of scenarios, right? Where you want to kind of run analytics based on relationship, for example. So about Tiger Graph, we started in 2012, but 2017 is when we actually started going to the market. So 5 good years our CEO actually took to kind of build a massive parallel processing graph database, the only scalable graph database currently available. And it's entire enterprise scale database with, I mean, as from our competition, we are like 40 to 300 times faster as kind of benchmarked by third parties. We are available on all the cloud platforms and on-premise. And our language, which we use, right, which is also very important, we have made it very similar to SQL, so that it's much more easier for people to adopt. Our customers include largest companies in all these different, different verticals. We have, as of now, we have 8 of the top 10 global banks using Tiger Graph in their production environment. And the use cases span from credit card fraud, which we talked about. I think we talked about a lot of fraud sort of scenarios. How do you detect fraud rings, trade surveillance, merchant analytics, right? Credit scoring, wealth management, these kind of scenarios, right? Use cases, they are actually using us. And it's not just in one, there are a couple of big, large banks who are not just using us for fraud. They are also using for other use cases like customer 360, KYC and such, right? So as I mentioned, from Tiger Graph point of view, we are the only graph database which can actually scale for like billions of records and connections. Others are very good for exploration, but for enterprise scale, it doesn't work. Now, I will cover some of the graph use cases. So I already kind of alluded to this. There are a variety of use cases. Obviously, today's focus is more on fraud prevention and AML. But obviously, when customer is investing in a graph database, and one of the things which was highlighted earlier is one of the trouble is to actually get all the data from even your lines of businesses together in one single place, right? So if you're really going to invest time to do that, why not actually kind of enhance the use cases apart from AML and fraud prevention to customer 360? You can do customer segmentation and recommendations and such things as well, right? But it all starts with a single step, right? Which is like, let's say, let me just try to find the customer and his master data, right? And try to link multiple silos of customer information together to get a kind of a system which helps me with KYC, right? So obviously the current KYC systems are in place and they are good, right? But there are a few things which they will not be able to kind of detect, right? Which where graph can be very helpful, where you have obviously a customer profile which is kind of fragmented, and you link two sets of data together, and that actually gives you a better visibility about a customer. So for example, in this particular case, I would not be able to know that this particular social media data is connected with this particular person if it's not connected via some other channel, right? Or some other. So it's all about connecting the dots, right? Where basically for KYC, it's really helpful. The second step is taking your demographics, customer demographics data, and layering with the transactional data, right? So you have all the customer information, his segmentation, date of birth, gender, addresses, bunch of information, right? From customer master data point of view. And then you are layering with the account information, transaction information. And using this, how can you uncover a certain kind of patterns which are fraudulent, right? This is also something which traditional systems will actually struggle, because you will end up joining a lot of, I mean, first of all, some of the systems will even not churn out any results because they will not be able to join, or they will take like probably, I mean, for some of our customers used to take like a day to actually run a query, which is not really feasible in today day and time, right? And second aspect is even the, I mean, so there are systems which are not even kind of performing. And the second aspect is the kind of information which is kind of uncovered by graph itself is also very valuable in many of the fraud detection use cases. And we will talk about these things as well. And the third thing I want to talk about is anti-money laundering, right? So, I mean, some of our customers are using us to detect the fraud rings, for example. I mean, obviously, when you combine the customer master data and transactional data and the flow of money, basically, right? And obviously, fraudulent, I mean, people are getting smarter and smarter, right? The people who are trying to fool the system. We have to obviously be one step ahead of them, right? But our systems are currently not supporting that in a way, right? So obviously, we want to do a 10-hop analysis, for example, right? I want to find out whether from a person to another person, there is a transfer made, and then it was made to some other person. But I am kind of limited by my capability of the system itself. I would stop at 1 hop, 2 hop, 3 hop, right? I will not go beyond that. And that will never uncover a lot of things which you can uncover. And I'll take an example. So this is one of the deep link analysis example, which one of our customers is kind of doing similar thing, right? So this is for the payment, right? So when a user is making a payment, we already know from our system and the graph we have actually built, consolidating and relating all the information, that this user has an account, he has a phone number, right? There's a device linked to that particular phone number. There is an email, there is a bank, right? Now, traditional systems will actually go typically until here, right? That a person is making a payment to an account, to a different account, right? From his account, and he's making this payment to a user too, right? So this is the regular systems or relational databases or regular analytics will do, right? But the power of Tiger Graph, because we are a distributed graph database, right? We can actually kind of go to 10 level hop in milliseconds, right? And I will show you maybe one example, if time permits, by running in one of the systems which has got 1 billion edges, 1 billion nodes and 4 billion edges. But in this particular case, where Tigraph really helps is running this in kind of milliseconds in all the directions, 10 hops, to actually uncover that there is a fraudulent device, and this second user where the money is transferred to, his phone number is kind of linked to that particular device, right? So you can do these kind of analysis, and you're not limited by the performance or these kind of technical challenges. And then you can build your use cases around this, right? So you are free to kind of use, kind of build and use your imagination to kind of counter some of these fraudulent activities. And the best part, as I mentioned, is you can do this in real time, right? That is the key value because of which 8 of the 10 banks are using us, because they see the value here and they can prevent the fraud even before it happens, right? They have put Tigergraph in the whole process of the transaction itself, where they use, at the last step, they use Tigergraph to actually find out whether this is a fraudulent transaction or not, and they will block the transaction at the same point, right? So overall, basically from the financial crimes point of view, some of the challenges which obviously a lot of customers have told us is the false positive, because when you block a transaction, let's say a credit card transaction or any sort of transfer, uh, traditional systems, if they are rule based, and if you have given, let's say, a certain amount, that okay, if it goes beyond this particular amount, then trigger a case, right, or stop the transaction. You are basically irritating that customer, because it's a false positive. Maybe it's a genuine case, and you are kind of irritating a high value customer who is making a high value transaction. And because your system is not really learning that, right, you don't want to do that. So you want to increase your accuracy, and graph is very explainable. So if you find something from graph, you can always explain it to regulators or to anybody else. It's much more easier to understand, because you can always draw it like this, and or kind of open the system and show them that, yeah, this is why I have actually kind of blocked this particular transaction, because it's linked to a device which is device to the user where the money is transferred to, right? So that is one very important part of using graph. So one is definitely the performance aspect of it, and the second is the explainable part of it, right, in fraud detection. So I already kind of talked about it, so I'll skip some of the content there. But using Tigergraph, you can kind of generate an alert in real time. Your front-end people who are actually working on these cases, the investigators, they can look into alerts, and they can kind of open it and understand all the information around it. Because what we have seen is 70% of the time is spent in kind of gathering information around an alert, which is generated by, let's say, an ML model. And it's very tough to actually gather the information and understand why a certain alert or a case has been generated, which is not the case with graph, right? Because here you can open and understand the relationship, browse through and understand the relationships, and see why the case has been generated. Also, obviously, we have a geospatial view, we have time series view. So for example, you can actually drag the timeline and see the time when the transactions also happened. So it's not just about seeing the current view and seeing all the transactions, but you can actually overlay along with the timeline, which is also very useful, which some of our customers like Bank of America has found. So now, just to kind of summarize the fraud part of it and the ML part of it, the typical rule-based approach obviously is the baseline for me, let's say. With ML and deep learning, obviously I can increase it by, let's say, 5%. So you can further enhance that with graph. So graph is actually augmenting your current system. So you can keep your rule-based approach, your ML-based approach, right? And on top of that, you can obviously use many of the key algorithms which is available in graph only and can be run on graph only, like community detection. And one of the algorithms is Louvain, which is very commonly used to find fraud rings. These kind of algorithms actually enhance your accuracy and also give more cases which are more relevant and accurate, right? So it's not wasting investigators' time. And obviously, one of the panelists actually highlighted about, having the humans in loop, because that is very important, right? So obviously, human insight and obviously the judgment they are making is very important, and we have to actually feed back that to the system, and that obviously visualization along with that increases the accuracy of your system. So there are a couple of data science capabilities, right? So there are, I mean, obviously I talked about the deep link analysis where, I mean, you saw the phone number was kind of related and the device was kind of fraudulent, and I can find like for four hops, 5 hops, I can jump and find out. One of the other, kind of data science capability which many of the users are using is there is a fraudulent pattern, and can I use that fraudulent pattern and match other fraudulent pattern and find if they are happening, right? So I've already tagged the pattern as a fraudulent, and I can use that to find other such patterns. So this is also very useful from the banking point of view, and obviously this is also used in a lot of other verticals as well, right? Similarly, I mean, these are on a high level the 7 data science capabilities, right, which Graph actually provides. So hub and community detection, which I talked about, right? How do you find that central guy, or let's say a central, a group of people who are kind of trying to make a fraudulent transaction? Because obviously not one, it's typically in the fraud ring kind of cases, they will make small transactions. I mean, there will be 7, 8, or it could be hundreds of people who are trying to make a small amount of transaction to fool the system. Yeah. Any questions? Okay. So basically, and we have geospatial, temporal, and obviously the machine learning feature generation, right? So I'll just conclude very quickly, since I'm not sure if, yeah. So we have 10 more minutes and we have question answer left. So one of the the largest bank, the second largest global bank, I should say, right? They are using us to detect fraud rings, and they are using us for 20 terabyte plus data, actually, right? And they are kind of, obviously, their earlier system was kind of running for days, and we have brought it down to 30 minutes. And that is on the, running algorithms like PageRank and Louvain and such things, right? Plus, they are also doing real-time fraud detection at the time of the fraud, right? So they are using us for multiple fraud use cases. And basically, this has led to a big ROI for them, right? So 35% uplift in fraud detection. US Bank is one of the another bank who is using us for AML use case. So again, a very big ROI of investing in a graph system. And obviously, because US is very regulated market, a lot of time their investigators were kind of struggling to close the investigation in a limited time. And that is where, even Graph helps. And our system can actually generate a SAR report, a suspicious activity report directly, which they can share with the regulator, where everything is kind of explained upfront. So that helps them to actually close many of these cases much more faster and reduce the false positives. So this is my concluding slide, basically. So, from Tiger Graph point of view, I think one of the things which I think Kushal highlighted is like Graph, as a concept, we have obviously studied in our schools and colleges, right? And Graph technology and databases have been there for 15 years. But why now this is actually picking up, and why 8 of the top 10 global banks are using Tiger Graph as of now is because it's very similar to AI, right? AI also was there as the theory for a very long time, but later, obviously with cloud, with processing power, now we have actually kind of found use cases for AI, and it's really at this point of time kind of seeping into everywhere, right? I think it's the same thing with the Graph database as well. And from Tiger Graph point of view, we have been pioneer actually kind of bringing the scalability in the Graph database. I think that is where the problem was, right? So none of the Graph database was scalable enough to deal with the current data set, current complexity, right? And the current, the kind of fraud use cases, for example, right? Because obviously fraudsters are also becoming smarter, and you have to actually navigate much more faster and much more wider to actually catch those kind of fraud cases. I think that's where Tiger Graph adds value, because we can process terabytes of data in milliseconds, right? Run complex algorithms like community detection and such things. So with that, I actually kind of end my session. Any questions we can actually kind of maybe cover now.
Thanks, Pawan. It was a great insight. So guys, opening the forum for questions. Devanjan, team.
Yes.
Vidya, yeah, please.
So guys, any questions you can also put in the chat box, and we already have all the panelists plus the audiences. So you can mention your questions on the chat box. We can take it from there as well, or anything. You can just raise your hands and just pop in with your thoughts. So yes, we are open for the Q&A or insights. Okay, we have a Senthil from Capgemini, Singapore. Mr. Senthil, please go ahead and ask your question to the panel.
Yeah, so Pawan, I think it was a very interesting presentation that you made around the KYC and fraud, right?
Sure.
Now, my question is that what are the prerequisites in terms of the data that is required to, to establish this use case Tiger Graph?
Yeah. So I have been part of, implementing MDM for a very long time. Around 14 years I've been doing MDM actually, Senthil, right?
Okay.
And in MDM also, you bring data from different places and kind of try to relate. But many of the MDM systems currently are struggling due to performance reasons and obviously regulations and such things, right? With Tiger Graph, you can actually, obviously you have to bring the data together, right, in one system. That is a given, right? But where we actually help is you bring this data together. We have algorithms on similarity, right? And many of these algorithms are open sourced, available on GitHub, which Tiger Graph has actually published. You can take this and use those algorithms to find identities, right? So your first step is to actually build the identity graph, right? What we call as identity graph, where you connect your customers to obviously you relate the customers due to addresses, emails, phone numbers, all the other attributes around the customer, and you build that identity graph as a first step, right? That itself will help you with the KYC part. And then you can slowly extend to other use cases like AML and fraud, where you have to bring in the transactional information. So you don't have to do everything in one shot, right? So you can start with a small use case.
Based on my discussion with some of the company CTOs or CIOs.
Sure.
They are saying, I've already invested X $million on Mantas or Maximize or any other existing data warehouse, right? So they can bring this, analytics on top of that in whatever is the open source they have. So we have also tried to convince them, saying that, graph technology is something different because you're going to establish the relationship, for the various entities that we are going to identify, right? Now, the challenge that we have is that what are the minimum attributes or data points that is required? For example, when you're doing a fraud, are we saying we collect overall at around 15 or 20 or 100 attributes across customer transactions and accounts for us to trigger this basic vanilla that you have as a part of Tiger Graph? So that is where we have a lot of debatable discussions going on.
Sure.
And that is where Tiger Graph, we don't get the clarity around what is required. Yes, you have a lot of open source and other things that is available, but what is that attributes that is required for us to trigger this vanilla frameworks that you have in Tiger Graph?
Sure. So I think you're talking about the fraud part of it, right?
So you want to go for this compliance or any basic thing, because your starter kits, you have the frameworks. How do you enable that? Because he's saying, we do understand that there are customizations that can be done, but what is the minimum you need for me to take it up to the compliance side or the business side and say, "Oh, this is where I put this graph." Now, for me to enable this in the environment, it's going to take 12 weeks or 15 weeks, and these are the quick wins that the business can get.
Got it.
Understand the customization will take much longer time, but what is that you can give me along with this graph use cases that you have?
Sure. So obviously, we always start with a small POC actually, Senthil, right? And that's where we actually help most of the customers to figure out their use cases, right? It should be use cases driven. You don't want to boil the ocean, right? So you don't want to bring all the attributes, everything. So for example, we work with customers to say that, okay, if the customer's use case is like, I want to find out fraud rings, right? For fraud rings, what do you need? So there are X amount of attributes only you need, right? You don't really need all the transactional information loaded into the database. It's not really needed, frankly, right? So obviously you have to think from use case point of view, short term, and obviously long term, what do you want to achieve? So let's say down the line, 6 months later, you don't want to again get into an exercise where enabling a new use case. So I think you should have a plan for let's say 1 year, 2 years, but obviously short term use case, limited set of attributes, and you can always add for the remaining attributes, right, which you might need for future use cases, you can always add later. So basically, the model is flexible from that sense. If you allow me, I can just share a very quick, a very interesting demo which will help answer this question as well, right?
Yeah, sure, Pawan.
Yeah, so I'll just share my screen very quickly. In interest of time, I didn't actually go into demo, but we have a solution which is already available, here, right, on Tiger Test Drive. So here, if you see, I mean, we have, for example, an anti-fraud solution already available. And this solution has, as of now, right, 1 billion vertices and 4.5 billion edges, right? Now, if you go to this solution, you can see some limited attributes which we have actually loaded here, right, which is relevant for us. And this is a simplistic model, right? So you have a user, there is a device, there is a transaction, there is a payment instruction, and there is a relationship, obviously, between transactions, right? So I think it all depends on use cases. So in this particular case, I will show you one example of a fraudulent, I mean, what I will do, I'll use a circle detection, right? So I want to find out all the transactions which originated from this user and came back to this user, right? Running across billions of kind of edges and nodes. And you can actually try this yourself since this is a public thing and you don't have to register as well. Now, if you see, what we have done here is we have actually executed this, and we found out, okay, there is a transaction started by this user and went to this particular user, and he initiated a transaction to this user, and then finally it circled back to this particular user. Now, this is what a graph database will provide you, and our job is to actually do it like in milliseconds, right? But again, the use cases, if you see in this, you don't really need a lot of information, right, Senthil? You just need basically customer information, either user IDs or such, and transaction, basically, right? That there is a transaction made, and maybe you can keep at this relationship level, you can keep amount or some of the very critical information, but you don't have to bring in all the transactional data. The actual transaction itself is important between two users for fraud detection, and obviously some of the other values like amounts and such things, but you don't have to bring a lot of data which is not really needed for graph analytics.
So basically, we are trying to get that minimal data point that is required to establish our connectivity or the patterns. Not actually zoom into the underlying transaction that caused the connections.
Correct. So you can zoom into, again, if that is the requirement, you can always bring more data,
more data points. Yeah.
If somebody is trying to explore, they can actually see, let's say, the time of the transaction, location of the transaction, and those kind of things. I mean, that is dependent on the use case. And let's say somebody wants to actually expose this user interface to their investigators. Obviously, it makes sense to bring that information. Whatever is required for that list.
Thanks, Pawan.
Yeah, sure.
Yes. Do we have any more questions? We would love
to. Pawan, Amit Goel this side. My query to you is, see, in the current world, while RBL Bank is like one of the entities, right? The transaction will flow across the multiple banks. So how do you figure out that this, like the one you showed right now, will flow back into, say, same customer? Because then it will not be a complete transaction, right? So how is it something that is possible?
No, that is true.
So how do you think where all it can be used?
So
as a use case can be implemented?
Yeah,
please.
Sure. So I think within your bank, obviously, you can actually do all sort of this kind of analysis, which we were actually looking at. We are talking to one of the banks in India, and where you can use, let's say, a third-party information, or some regulator is actually providing some sort of, information where a particular account is fraudulent or the person is fraudulent. I think there are certain regulators which actually share that kind of information. So what you can do in this case, obviously, I mean, the circle detection and these kind of things you can only do if you have the transaction information. And you rightly said, you can only do within your own systems, right? Within your own database. But you can always augment that information with any third-party data, or regulator is providing some sort of data, right? And you can use that information for your own fraud detection. So today, a transaction is happening, and you have already kind of you take that regulator information, a particular person is, kind of fraudulent, or a device is fraudulent, right? And you actually link that information with your customers, you can always find out, and with obviously the multi-hop, that the current transaction is suspicious or fraudulent. So I think there is a limitation in that sense. You cannot really do across. Obviously, you don't have access to all the other banks' information. But obviously, most of the countries, regulators actually provide this kind of information back to each of the banks, which can be utilized for, linking and fraud detection.
Sure.
Yeah.
Follow-up question on this one.
Sure.
It will be linking across the database, right? So if we have multiple database, Oracle, SQL, open source, unstructured, so can it link through multiple database and come out with the linkages, or does it require to be in a particular data source, and from there only it can be pulled out?
Yeah, so we can definitely, so for graph to work, and since I highlighted about the performance aspect of it, the whole performance, you get if you load the data in the graph database, right? So we actually provide tools to actually load data from any kind of source, right? So there is a data integration capability built in the tool as well, or you can use your own ETL solutions to load data into the graph database. And that's where Senthil's question was there, right? So what data to load? I mean, how do you limit? So that is obviously dependent on the use case. So once you load the data into the graph database, and you run some of our similarity and other algorithms to kind of link it, then you can actually kind of run many of these graph algorithms we are talking about.
Sure.
So first step is actually bringing that information into the graph.
Got it. So can this solution also be used for MDM as well as, like you just touched upon KYC, AML, and fraud detection, right? So can it be also be used for MDM?
Yes, definitely. So as I said, I have been doing MDM for a very long time, and we always struggle with some of the either regulatory issues, a lot of performance issues, right? Those kind of issues. And definitely, many of our customers, and few of the customers in the banking domain, but there are some customers like AT&T and others, right? They have actually built United Healthcare, for example. They have built a customer journey out of tyGraph. So they have used this to actually bring all the information. So MDM obviously limits itself to customer master data, right? I think that's where it stops. But in tyGraph, what you can do is you can bring in your transactional data, your interaction data, right? So a lot of customers are actually using us for, like, let's say, call center interaction, right? So those kind of things as well. When a person is calling you, a customer is calling you, you get to see his whole activities, his sentiments around it, right? Recommendations and those things. So there are a lot of such use cases which customers have implemented using tyGraph. Since today's session was more focused on fraud, so I kind of limited myself there. But yeah, that is a very valid use case for tyGraph.
Sure, thank you.
Yeah.
So thank you, Pawan, for sharing your thoughts and answering all the queries. So Kushal, I think we are dot on time, and I think it's a wrap up. So over to Mr. Kiran, Kushal, or Pawan. Any final thoughts that you would like to share? And we do the closure.
A few thoughts from my end, definitely. One, that yes, good question, Amit, whether it can replace MDM. So this is one of the areas when we talk about customer 360 degree, and this is one of our problem statement. So I have evaluated it can do. Second, for the attribute question which we received, okay, just to tell you, and I come from a very strong risk and compliance background, and even implemented multiple fraud solutions. Use cases and attributes, and Pawan, this is again for you also, need to be selected on the treatment methodology. The core data scientist will always look at that, and otherwise just picking attributes and expecting it to follow the graph databases and to get a wonderful result out of it is not possible. So these are a couple of inputs from my end. So coming back to the subject is that the problem statements, we all are there for you to work out. Myself, Kushal, Pawan, we can work out. So each problem has a different treatment, as told by Debanjan very clearly. In healthcare, if you don't know healthcare, you cannot predict COVID just by having an algorithm, right? So to So Debanjan, Amarnath, all whatever viewpoints are there, we as a team combinedly Care and Tigergraph are there to support you, to help you understand what it can do, and we could do small POCs with you to see how we can build out. But definitely, mm, we got some mentions. All those use cases I've been hearing too, like Amit said, the reverse circular way of reinserting, the algorithmic output into the database. Very good to say. Can Tigergraph do it? Yes, but there will be some amount of other effort also required. So let's be a little honest onto that. Okay. And yes, it's a great tool which can actually cut down 60%, 70% time to get business outcomes, what we all require. But yes, the energies around the rest of the 40% need to be analyzed where they are, because suppose, you cannot say that compliance shifted its regulatory requirement from credit portfolios to credit singular base or the level 1 base customer. It's not easy. Then it is not. Let's be a little honest. It can do it faster, but again, the algorithm needs to be set. As somebody told me, train the model and all. So here you need to train the graph also, the graph database. And once again, I and Kushal, we are trying to tell you the same thing. Yes, but we understand this path. We've been walking on this for some time. Wherever help is required, we're there to support. Yeah, that's all as a closing note from my end. Kushal, now over to you.
So I think you covered it very well, Kiran, and I'm just adding one thing. When you're looking at graph coming into the scenario, it is just giving you more power. It can process more data. It can go deeper in the relationship, which right now you don't have a way to do with the conventional technologies. And it can also do the transaction as well as the analytics for you, that which you're talking about real-time use cases, which again, conventional technologies will struggle with that. So if your use cases are there, which needs huge amount of data, finding deeper relationship and a quick response time, graph is the way. And that's the way I'm putting. So we are not looking at replacing, or it's not rocket science. It's basically just giving you that power which you're missing as of today on these 3 points, and that is where graph coming in. And as Kiran nicely covered, that every use case will have its nuances, and you guys are already working on different use cases on anti-money laundering or fraud. So you're already doing your work. You have the data you're using. The approach we are taking with a lot of customers is basically looking at what you're doing and see that how graph brings value there, making it faster, better, more accurate for you, and then adding more attributes going forward, flexible way to do that. So it doesn't disrupt what you're doing. It actually adds value to do in that way. But again, it will case-to-case basis, we can get into that. So we are here. I'm sure today was a limited time. We can't cover such a vast subject in 1.5 hours time, but you have been a good audience. Pretty good inputs. Kiran, thank you for moderating this panel. Pawan, thank you for your slides and inputs. I'm sure we are open. If you have questions, please feel free to send it to us. We are there on LinkedIn, other social media platform. Please feel free to reach out to us directly or write to Ekta, and they can channel your queries or concerns to us, and we can respond back to that.
Okay. Thank you so much, Kushal. Thank you so much, Kiran. Thank you so much, Pawan, for answering all the questions. Of course, on the closing, I would like to thank all the thought leaders and our partner Tigergraph and Care Edge Risk Solutions for sharing your insights and taking out your precious time, being with us and sharing interesting insights. Rightly said by Kushal, the time was limited, the topic is vast, but definitely we are here, the Brinalytics, to help to connect to Care Edge Risk Solution and Tigergraph. Let me tell you something quickly about Care Risk. Of course, Mr. Kiran has said much about it. It's a wholly owned subsidiary of Care Rating Limited and has over 15 years of global experience in providing cutting-edge risk and compliance solution to banking and financial institutions. So, of course, when the Brinalytics team reaches out to you with the certificates and the appreciation certificate, we'll be happy to reconnect you with Tigergraph and Care Edge Solution Company. So, thank you, everyone, once again, and have a lovely weekend and stay safe, everyone. That's all from mine.
Thank you, Ekta, and thank you once again for arranging this, and your team is superb. Thank you so much.
Thanks.
All the thought
Thank you.
leaders for making it. Bye.
Thanks.